Okay, so when we're doing logs and we see something like this where the equation has the x value, the unknown, is in the exponential box, which is this thing, right? What we have to do is we have to take the log base. In this case, it's 3 because the exponential is attached to a base of 3. So what we do is we say we want to undo the exponential's base. To do that, we have to use the opposite function, or the reciprocal if you really want to be fancy. So in this case, we say log base of 3 to the 2x minus 17 equals log base of 3 to the 5, right? Because what you do on one side, you have to do to the other. So log base 3 cancels out the exponential 3. So what you're left with is, if these cancel, you're left with 2x minus 17 equals log of 3 to the 5th. And then after that, it's just basic algebra, right? You go, to cancel the 17, we go log of 3, 5, plus 17, right? Because we want to cancel the 17 here. And then to get rid of the half, to get rid of the 2, all we have to do is multiply by half. So x equals half of log 3 and then 5 plus 17. For this other question, hold on. For this other question, 7 to the 3x plus 2 equals 50. Well, what exponential base do we have? We have 7 as the exponential base because we're trying to get 3x plus 2 by itself, right? So what we have to do is we have to take a log base of 7, because remember, log cancels out the base of the exponential. So we have log 7 of 7 3x plus 2 equals the log base of 7 to the 50. And then since we know that log of 7 cancels out base of exponential 7, we go cancel, cancel, and then what we do is with that we can take down the equation, and it's 3x plus 2 equals log base of 7 to the 50. And then we know how to cancel 2, so we go log base of 750 minus 2 equals 3x, right? And to cancel the 3, all we have to go do is multiply by 1/3. So log base of 750 minus 2. Okay, so this is how it looks. This is how log works. So if we go back to the question we had before with log natural, I'll just wipe this out first. The key to remember is that Euler's number is still a number. It's like about 2.71. And since it's like that, we like to give it a fancy name. The log of e equals log natural. It's not anything special, it just means the log of e. So it's still technically a log. So what we have to do here is we have this massive fraction, and we want to get r by itself. So what we do is we say, okay, we have a exponential function e, and we want to cancel it. What cancels e? Well, that be log natural. So the opposite of Euler's number, e, is log natural. So we take the log natural of both sides, to get 65 multiplied by r by itself, right? And we know since log natural is the opposite of e, just like how plus and minus is the opposite of each other, we go cancel, cancel, and all we're left with is 65r. the log natural of this number equals 65r. Okay, now we have to think, how do we get r by itself? Well, that's simple, right? We just multiply by 1 over 65 because we need to isolate r. So we go 1 over 65, multiplied by the log natural of 7618,847 over 1043497. And that is how you get r. Now, if you turn that into a decimal point, it'd be what you got is like 0.02 or something. And then you keep going. But yeah, that's really up to you. But yeah, that's just basic explanation of logs. And your calculator log is automatically set to log 10 and then like to x or something. Like, that's why it won't work.